Good morning, everyone. Good evening, everyone. I guess we are live. Let me just check once. Mm, Yeah. So we will wait for 5 minutes, then we will gonna start today's post-contest discussion. Okay. Yes. Yes, how many problems did you solve in the contest? Mm. Oh. So, guys, today's contest was quite hard. Like, as you can see, the submission rate from D to then above, they all are like quite low. And yeah, E was very hard to even process what we have to do. I didn't try today's. No problem. You can just absolve it now. So let's start with the today's post contest discussion. And hello everyone. So in this contest, the first problem for the division 2 was odd string. Okay. In this problem, you are given a string S of length n consisting only of lowercase English letters. A string is called an odd string if and only if for every pair of indices I is less than j such that Si is equals to Sj and the distance between them is odd, which means j minus I is odd. In other words, no two equal characters are allowed to appear at the even distance from each other. Okay, so you are allowed to rearrange the characters in the string in any order. Determine whether it is possible to rearrange S such that it becomes an odd string. Now, so in this problem, you are given with a string S, say A, B, C, A, B, C. Now you are asked that it is a what string name of the name was odd string. Okay, so it is a odd string only when the two characters which are same, like for this string a is same and the distance between all these characters, like if there are multiple a's, say a and there are some distance between them, for from every a to every other a, the distance between them must be odd. Okay, so you can just remove it, and now the distance must be odd. So it will be when all the characters have this functionality, like all the distances are odd. we can call it an odd string. Okay, so what operation we have? We can rearrange the string. Now, first of all, what are the odd numbers we need to focus on? So there are odd numbers starting from 1, 3, 5, 7, and so on. Now, which is the easiest odd number to work on? It's 1. Now, if distance is 1, then my string, if I want to rearrange this in with all the elements having distance 1, the string will look like this. Yes or no? Was it? It was 3. It's subset enumeration. Some pretty sufficient. Subset enumeration. I will say it's like you need to know somewhat bit masking, and then you just need to do a recursion on that. I will explain that. Okay, so as you can see, the both of the A's have a distance of 1, both B's has distance 1, and both C's has distance 1. Yes. Now, let me ask you one thing, like I can rearrange them in consecutive manner, right? I can rearrange them in consecutive manner. Like um, if there are multiple A's, I can do this. Yes or no? Yeah, 7 raised to power 4 solution. So I can rearrange in this form. The answer is no, because there is one condition that every A must be at the odd distance with other A's. So if you are trying to place to A at some odd distance, it can be 1, 3, 5, or 7, or anyone. So if you try to place somewhere at some distance, like say 3, so your numbers will be, we can take any example, right? So let's take an example for uh, when s of 2 is a, and s of with the distance 3, say s of 5 is a. Now if there is one more a, even if there is one more a, and you want to place it so that it has a distance odd from s2 and distance odd from s5 also. So for distance odd in s2, you can place it on 3. S5 it is filled, so you will place it on S7. Then you can place it on you can say A9, S9, right? So as you can see one thing, because one A will be placed, because the distance is odd, so one A will be placed either on odd or even value. If it is on odd value, the other A will be placed on even value. If it is on even value, then other A will be placed on odd value. Okay. So when you are placing both of them on an opposite parity, odd for even and even for odd, any other A which you want to place will contradict one of them. Always. It will always be true that it will contradict one of them. Which means if you try to place A in any of the value like S3, then it will contradict with S5. If you try to place it on S8, it will contradict with S2. So this will happen. Okay. So now this thing is called pigeonhole principle, which means you can't place you can't place three or more than three A's, right, in the string. So if any string has a character whose frequency is greater than 2, then you can just return no directly. Okay. So our solution will be any character with frequency greater than equals to 3, you can print no. else it's always true, right? So time complexity of this solution is big O of n, and space complexity of this solution is big O of 26 for making a frequency map or for the strings, right? Now, if you look at the summation, is yeah. So in the summation, as you can see, what I have done, I have taken inputs n and s, then I made a frequency array of size 26 for all the characters. Now I have iterated over s and updated my frequency in the frequency array. I have made a Boolean flag which determines if there is any frequency which is greater than 2. Okay. So I have iterated on frequency. If there is any frequency which is greater than 2, you can just make flag false and break out. If flag is 2, you can just output yes, else no. Okay. So this is an easy code to do. And the solution is all quite easy, not very complicated. So if this is clear, then we can move towards the second question. Here you can say the space complexity is big of 26. These are ones, big of ones, and this is space complexity big of 26. Then iteration is big of 26 also because you just iterating on string. And if string has n is 1e5, then your iteration is big of n for this. Correct. Okay, so we can move towards the second problem if this is clear. All right, no response. Good. Yeah, so we are moving to the second problem, which was odd operations. This is also a good problem. In this problem, you are given with an integer n, and you can perform the following two types of operation on it. Okay, first one is digit subtraction, in which you can choose any digit present in the decimal representation of n and subtract it from the n. Second one was digit reordering. You can rearrange the digits of n to form a new number. Okay, so and one thing is clear. It is always that you cannot put zeros in the front, right? You need to determine the minimum number of operation required to make n an odd number. Alright, if it is impossible, you can just print minus. So in this problem, let's discuss case by case. Okay. So we are given a number n and we need to make it odd. And we have two type of operations. First one, subtract any digit d from n. So it will be n minus d. Second operation is rearrange n, and you can't put zero in front. Okay. So tell me one thing. If n is already odd, then answer is 0. Clear cut case. So let's write in form of cases. So case 1, n is odd. Okay, then answer is 0 because we don't need to operate anything. We can directly say in 0 operation you can just make n odd. Case 2, if n is not odd, then which means this is false, and if n is less than 10, which means all the numbers 2, 4, 6, 8 and 0, I guess 0 is not there. Okay, so 2, 4, 6, 8. So in 2, 4, 6, 8, can you make them odd ever by subtracting a digit? There is only single digit, and when you subtract the single digit with this, so it will be just d minus d. which means it's 0. So if it is 0, then you can say it is not possible. So for n less than 10, we will print -1. Case number 3. This is a good case. Like maybe some people uh, lose this. Like if there is any digit odd, which is odd inside n. For example, a number 2, 3, and 6. Okay, this is a number. Okay, 236. Now, as you can see, 3 is odd. So if I subtract 3, the number is always odd because even minus odd is always odd. Okay. So if there is any digit which is odd and present inside n, we can say the number of operations is always 1. Okay. So in one operation, I can transform the number into an odd number. Case number 4. Okay. Now in this case, there are all evens. All evens. Now how will you make a number odd if it is all even, like 2, 4, and 6? If this is a number and say one more number, 2, 8, 2. Okay. These both are numbers. How can you make them odd? First of all, if you look at this, the 10th place is 6, right? And I know the number before 10th is also even, as I have checked all the conditions of odds. So in this condition, all the numbers are even, all the digits are even. So any digit before the last digit is also even. If this is even and I can make this odd, correct? I can make this 3. How? I can make this digit 3 by subtracting a number in such a way that it generates carry. If carry is generated, which means the number will be converted into odd number. Okay. So how can I generate a carry? So I to generate a carry, I need to subtract a digit d larger than last digit. Okay. This is correct, right? Is this understandable? Like if I need to generate a carry on the 100th bit, or you can say like second last bit, so I need to subtract a digit which is larger than the last digit. So if the digit is larger than the last digit, I will generate a carry. And when I generate a carry, so in this case, which was 246, the largest digit is 6, and it is also same as the last bit. So in this case, I need to perform one operation to perform 246 minus 6, which is 240. Then now if it is 0, every digit is larger than 0, right? So I need to perform you can take any of the digits now. You can take any digit. So it will be converted into 2, 3, and 8. Now you got one odd digit. So when you subtract an odd, you will get an odd number. So how many operations I have done? 3 operations. Okay. Now for the second example which I have taken, 8 or 282, in this you can see the last digit is smaller than the largest digit in the number, which was 8. So I can say maximum digit. So last digit is less than maximum digit. So in this I can directly subtract the largest digit, and it will be converted into 2, 7, and 4, I guess. Okay, so now you get an odd digit in one operations. Then you can just subtract that odd digit and you will get a number 2, 6, and I guess 7. 2, 6, 7. Okay, this is an odd number. So in this, you get two operations. So in this, I have made all the cases and I have iterated. So the maximum number of operation is 3. You don't need any more operations than 3. Okay. So now you can just code it. How will we code it? Let's see. Okay. So as you can see, I have taken n as input and I have checked if n is already odd, you can just output 0. Now I have converted s into the string. Now take the length of s. If length is 1, which means it is less than 10, and you can just output -1 for that. Correct? Because 2, 4, 6, 8 cannot be converted into an odd number. Third thing, what I have done, I have checked if there is an odd digit present in it. This is my max, which means the maximum digit in the n, and last means the last digit, which is s dot back -0. Okay. Now I have iterated over s and checked for each digit. If it is odd, then I will update my flag and take max with the maximum digit. Now, if you get an odd digit, you can just output 1. If your max digit is larger than last digit, which we have discussed in the case, you can output 2 as you can output 3. That's it for this problem. Okay. Now, if this is clear, we can just move to the third problem. Any doubt in this? You can just respond in the chat. I will read. Sorry. Hmm. Okay, so we are moving towards the next problem. Okay. Which is rectangle coloring. Okay. So in this problem, what you are given a rectangular fence with length L and width V or W. The fence has 4 sides and total length of the fence is 2 into L plus W, which is perimeter of rectangle. Okay. You have exactly enough paint to paint the entire fence using 3 colors: red, green, and blue. Okay. Let the total available paint of each color be R, G, and B, respectively. If you don't mind, I'm gonna share. God forbid. Um, you can ask Mahesh for that. Okay. So let the total available paint for each color be R, G, and B, respectively. Then R plus G plus B is equals to 2 into L plus W, which means that total color what you have is equal to the total length of the fence, which means you cannot uh, well, you cannot do something like you paint all the fence and still have some color left, or you painted the fence and you don't have enough color. Okay, you have the exact same color amount of color. Okay. Now each unit of paint can cover 1 unit of length of the fence. Okay. Painting cost, each side of the rectangle must be painted completely. Okay. And a side may be painted using one or more colors. And the cost of painting a side is equal to the number of distinct colors used on that side. And we need to determine the minimum total cost. Okay. In this problem, you are given with like you have a rectangular fence which has length L and W width. Now you have 3 colors R, G, and B, whose total amount R plus G plus B is equals to total parameter of this fence, which is 2 into L plus W. Okay, so you need to paint in such a way that the cost is minimum. And what is the cost means? It means the number of distinct colors used on single site. Okay. Now, from here, this question gets little bit good. Now, if I ask you one thing, there are a lot of ways to color the fence. Like I can completely paint this as red, okay, or I can completely paint it as green, or I can completely paint it as blue, or I can paint half of it as blue, then red, or blue and green, then either it will be green and red, correct? Or I can do something like that, red, green, and blue, correct? So there are multiple ways to do that, right? Now, if there are multiple ways, how many ways are there? There are three colors, R, G, and B. So for every side, either I can do a color R, or I can do a color G, I can do a color B, or I can do a combination of RG, GB, RB, or RGB. So how many total combination are there? 7 combination are there. And if I mask them, it will be look like uh, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So this is means R, this is mean G, this is mean B, and you can say clearly this is for R, this is for G, this is for B, this is for RG, this is for RB, and this is for GB, and this is for RGB, all complete together. So I can number them 1, 2, 3, 4, 5, 6, and 7. Right? And I can also write the cost for them. So cost for single R is 1, single G is 1, single B is 1, RG is 2, RB is 2, and GB is 2, and then RGB is 3. Okay, this is clear. Now, if I ask you what is the global minimum cost and global maximum cost, which means you cannot exceed the limits. There are four sides, and maximally uh, you can paint all four side by single color. So cost will be 4, which is 1 plus 1 plus 1 plus 1. Correct. Or you paint every side with 3 colors. So your cost will be 3 plus 3 plus 3 plus 3, which is maximum 12. So your cost will range from 4 to 12, right? It cannot go below 4 and it cannot exceed 12. Okay. So this is also clear. Sorry. Now, what we can do? We can use a greedy method, right? Because we can iterate over all these values and we can also iterate on 7 values. We can make a brute force greedy, like I will check for each of them, for each of the combination, which is the minimum cost. and I will take that minimum cost out. Like start with the first fence, try all seven combination, try on second fence, try all seven combination, try on the third fence, all seven combination, fourth fence, all seven combination. So the total complexity will be 7 raised to power 4, which is very low, like it's near about 49 to 49. Okay, so you can do that in this. Now, after that, you can just output which is the minimum most fence cost is. So this is clear. We can, if this is clear, I can just move to uh, the approach and how to implement the problem. Okay, let's do this. Okay, now tell me one more thing. Okay, what I'm saying. Oh yeah. Okay, so if I'm painting a fence with one distinct color, I don't know which color. What is my cost? If you don't know which color I'm painting, the complete painting complete fence, and I'm not telling you which color. But can you tell me the cost for that? Tell me. If I don't tell you which color I'm using, and I just told you that I will paint the complete fence with that color. Can you tell me the cost? It's one. It's always one. I'm not telling you like I have painted it with R, or I have painted it with G, or I have painted it with B, but the cost will always be one. Any color I have chosen, the cost will not affect by that. If I am painting the fence completely with the same color, same case. If I am painting the fence with two colors, two distinct colors, what will be the cost? I have not told you that it is RG or GB or RB. You don't know about these. The cost of colors is 2, and it is fixed like 4. How 4? I am talking about a single fence currently. Okay, I am talking about the single fence. So for single fence and one distinct color, the cost is 1. A single fence, two distinct color, the cost is 2. If I am painting the fence with 3 distinct colors, which is RGB, the cost is 3. Okay, here single side. I am currently talking about a single fence, not the perimeter. Okay, I am not talking about the perimeter. I am talking about a single fence right now. Because what is our approach? Our approach is we will first work on single fence, check all the 7 combinations, then call the recursion for the second fence, check all the 7 combinations, check call the recursion for the third fence, check all the combinations, and then fourth fence, check all the combinations. Okay. So we are first working on single side. So our recursion will work on single side only. It won't work on multiple sides at one time. Okay. So which means the cost is 1, cost is 2, and cost is 3 is static. There are 3 combinations. So mask for them were, for one their mask was 001, and for you can say 2 mask was 3, I guess 011, because you are using 2 colors, and 7 you can take mask for 1. Like There are multiple masks, but you can choose any of them. I have chosen 1, 3, and 7 for this case. You can also choose 0, 1, 0, which means 2, or you can choose 1, 0, 0, which means 4. Doesn't matter, but for simplicity, you can choose the first mask which was appearing. Okay, now, now this is done. I need to ask you one more thing. Uh, how can I tell you? How can I, no, sorry, how can I tell that if I'm painting a fence using any of the three condition which I have talked about, using any three conditions, these three conditions, either it is one color, two colors, or three colors. Okay, so any three conditions, I how can I tell that the fence will be painted? Fence will be painted without error. Error means like you are not overflowing your uh, color demand. Okay, so you can tell this by the total amount of color must be greater than equals to the length of side. Okay, the length of fence or side of the rectangle. Okay, so this is my formula, which means if I'm if I've taken this side of the rectangle bay, or you can say this is my rectangle, and I have taken this side, and it has width W, and I am trying to paint it with two colors, say R and G. So the sum of R and G available right now must be greater than W or equals to W. Correct? Only this way, if this is true, then I can paint it with two colors. If it is not true, I can't paint it with two colors or a singular color for R and G. Okay. Answer will be 24, 5, and 6. Yeah, answer can be 4, 5, or 6 also. But I was talking about the answer cannot exceed 12. I want to explain that there are only these cases you have to consider. Like you are painting three colors on this side, three colors on this side, three colors on this side, three colors on this side. So this makes a total answer of 12. But you are correct. Like if you are painting on this side and this side with the same color, you can just copy the color on this side also. So it will decrease your color amount. But there might be a case in which it will be increased. Like if I take a case, in which one color is this? So it is increased here, increased to 3, and three, into 3. Okay, yeah, it cannot increase 6. Like if you try to make it, it won't increase more than 6. But maximum, which topic is this? Like we are talking about greedy and recursion right now. Okay, and for the color combination part, only this much is basic bit masking. This is basic bit masking. I've just masked all the colors in form of numbers so that I can identify which one is which color I'm filling with without using R, G, or B values. Okay, so let's dry run the test case. Let's take this test case 63954. 63954. Okay, so this is L, this is W, this is R, G, and B. So First of all, what I will do, I make an side array. This is my side array, and I have assigned all the sides on this. Okay, so first side is 6, then 3, then 6, and then 3, because rectangle is LW, LW. Okay, so I have put 6363 in the side array. Okay, now you can mask all the colors R, G, B, RG, then RB, then GB, then RGB. Okay, and while masking you can put the cost of them also. For R the cost is 9, like so cost means the length for here. For G you can paint 5, for B you can paint 4, for R and G total you can paint 14, for RB you can total paint 13, for GB you can total paint 9, and for RGB you can total paint 9 plus 5 plus 4, 18. Okay, right. Now you can initialize your answer as 13, because as I've told that maximum is 12 globally, so you can take answer as 13 or infinity, whatever you want, or 7 if the code works. I'm not sure about 7, but yeah. Okay. Now you can just call your recursion on three things. First is your index, which is means which side you are on, 0, 1, and 2 and 3. Second thing, you can call on cost, and third thing, uh, your current mask array. Okay, current mask array. You can call recursion on these three things. Okay. Sorry. Now let's start with recursion. So we are with mask 1, 2, 3, 4, 5, 6, and 7. Say side is currently 0, which means index is 0. We are currently on first side. Correct. So we will start our loop and check how for side 0 which all combinations are true. Okay. So how will you do? You attempt from index 0, which means 1. You can fill it with 1. Side 0 was 6. Correct. And R, and keep in mind this array. Okay. So you can fill it with R. Okay. Because R is greater than equals to 6. You can fill it with RG. It is greater than equals to 6. You can fill it with RB. This is greater, and you can fill it with GB, and you can fill it with RGB, all three. Okay. Now, as you know, we are doing recursion. So if you fill it with R, then it will call a recursion in which your R has side 0 has been filled with R, which means your cost of R is 3 now, and then your updated uh, mask will come. Updated mask will, which means that you have to update these values, because when you update 3, then it will also get decreased. So it will be 11. Oh no, it will be minus 6, like 8. Then it will also decrease minus 6 by 7. Then it will also decrease 12. Okay. Then you again check for all the fours, all the 7 sides. For this side equals to 1. Check all the 7 combination which all are true. Okay. Then from that, make again the recursion tree, which all possible combination you can do for side is equals to 2 by updating the mask. You need to update mask at every step. Okay. If you forget to update mask, then your question will be wrong. Then update mask and check again. Okay. Then call again recursion. Side is equals to 3. Update your mask and give for the side equals to 3. When you get the side equals to 3, which means you are at the last side, and when you complete that, you can just return your minimum answer. You can make the answer as global value and take minimum at all the steps. Okay. So this will always give the smallest possible answer. Hello. Okay. So is this clear? Like for 6363, the best way is to use R for side 6. Okay, so we can use R for 6. Then you can use again R for side 3. So your total cost of R is completed. Now you have a side 6 and 3 left. Now for 3, you can either use say G or B. I have used say G. So after using G, the cost of G will be 2. Then I can use 2 plus 4 here, which means G and B. So total number of distincts is R1, 1, again 1 and 2. So 1 plus 1 plus 1 plus 2, which is 5. So answer is for this is 5. Okay. So recursion will take care of all of these. We don't need to do anything. Is this clear? If it is clear, then I can move towards the code. It's not a very hard code. You can just, if you look at it, it's very small. Okay. So let's see the code. As you can see, what I have done, I have taken inputs of my variables. Then I have assigned my side array as L, W, L, and W. Okay. Then I have iterated over all the steps from 1 to 7 and updated my mask. Right. I made a supply array, which means the number of paint I have currently. So if it is and with one gives if it is and with one, then I can make my color R for the supply array. I'm currently filling just my mask array. You can just tell like this. Oh, I guess this is easy step. I don't need to explain, but say. So I have taken my mask like this. RGB, R is currently at position 1, G is currently at position 2, B is currently at position 3, 4. So by iterating from 1 to 7, whatever bit comes when you are taking AND with it, like for this is 100, then 010, then 100, then 011, 101, 110, and 111. So as you can see, when one comes, which means I am taking only R, so take the sum of R. When 5 comes, which means B and R are together, so you can take sum of blue and sum of red in the mask array, so you can just fill this thing first, which means R is 9, G is 5. I'm currently just filling this. Okay. So after filling this, you can make an answer as infinity. I'm not sure that it will work on 6 also. Like, let's check. Uh, I'm just checking if it is working on 7. Mm. Oh yeah, it work on 7. Okay, so answer cannot exceed 6. Okay, so your answer is consisting in the range 4, 5, 6. All right. So now I have made my vector P and my current mask is from all four filled as 0. Now in your recursion, you can just pass your current side, cost, and P array and the current array. Okay. So now how P and current array is filling, let's see. First, what I've done, I have made answer globally. I made the side array globally, RGBS globally, and supply arrays globally. Now order is 1, 2, 3, 4, 5, 6, 7. All the 7 masks are there. And for each of them, because 1, 2, 4 have single bit on, so there is one mask, one cost. 3, 5 has 2 bit on, 3, 5, 6 has 2 bit on, so the cost is 2. 7 has 3 bit on, so cost is 3. Now, in the recursion, you have sent the index. Okay, if your answer is 4, any point your answer is 4, you can directly return it because 4 is the lowest value which you can have. If your current cost is exceeding your answer, then also you can return because it's not worth it. If you are having a cost of say 5 right now and you are getting the cost of 6, you can just return it, break out from that because you already have a better cost. Now, if your index is completed, like your iteration is completed from 0 to 3, you can just check your current mask array, and if it is a valid mask array, then you can just say your answer is the cost and return it. Okay. Now you can just take the start as 0. If your index is 2, which means your side is 2, your start will be at P0. If your side is 3, your start will be as P1. Now start from I to 7. Go check all the conditions. Your next cost will be cost plus cost I. Okay, this is same thing. You are updating your cost. If your next cost is greater than answer, you can just continue because you don't need that cost. Now update your P array with the particular side index and your current mask as the which order you are currently on. Okay. Then you can call your recursion for the next side with the next cost and updated P and updated current mask array. And if your answer is ever 4, you can just write directly return it. Okay. Now how the check function is working? You are sending the current mask array. It is iterating all the masks from 1 to 7. Your need for them is 0. Check for all the sides. If any point of time that your current mask and the current index, which means the 1 2 3 4 5 6 7 you are currently on, is equal, or you can say the same bits are on that, you can do a need plus equals to side, which means you are updating your cost for that. And if your supply of mass, which means your value is ever get loss lesser than the need, which means what we are doing that by updating the array, we are checking right now if I painted it with red, so my cost of red has been decreased by 6. So if I can't paint it with the red completely, I need to return false because red is not the correct combination for the particular side. So you can return false, and then else you can return true. Okay. So this was the question. I guess there must be a better way to solve this because I have solved it in like a lot of time after being stuck somewhere. Uh, there might be some better approach for this, but I know that I have to do a recursion and some bit masking concept in this. So I have greedy and bit masking. So that's it for this problem. Any doubt in this? Anyone, any doubt? If there is nothing, we can move towards the D problem. Right, okay. So let's move towards the D, which was three strings easy version. In this problem, you are given with there are P, Q, R, B, the binary strings of equal length L. Define PQR as the minimum total cost of transforming Q into R using the following rules. You may flip Pi or Qi for any index I is less than equals to L, and each bit is flips, which means 0 converted into 1 and 1 converted into 0 at a cost of 1. So you can flip the any bit of Pi or Qi, P or Q, and it will be converted at a cost of 1. After all the flips are completed, which means we have to do the flips first, then you have to do this operation. You may perform any number of valid swaps in the resulting string Q at zero cost. Okay, a swap of indices I and j is a valid swap if and only if the final values of pi and pj are equal. It can be proved that it is always possible to transform q into r using above rules. You are given three binary strings a, b, and c of length n. You need to compute f, a, b, c. Okay, so you need to compute what is the minimum total cost of transforming q into r. So any approaches for this problem? Any कुछ कोई भी आइडिया लग रहा हो? Any idea? Any random like theory you are coming with? We can do this, or there is something need to take care of. Anything like that. Question is, you are given with three strings p, q, and r, and you need to find minimum cost of converting q into r. Wait, if I need to convert q into r, what is the reason of p? Anyone? I have just read the question, so you can check out here. What is the meaning of p if I need to just convert q into r? What is the sole purpose of p? Anyone? Look, the p follows the main purpose here. You can rearrange the bits of q only if there are some operations, which means in first operation, what you can do, you can uh, swap bits of p and q. Okay, so 0 converted into 1 and 1 converted into 0. And after all swaps, you can replace bits or swap bits at index ij only when pi is equals to pj. Okay. So if you want to swap bits on q at some two indices, you need to see if those both indices are in p have the same value or not. For example, if p has value say 10010 and these two bits are same, so if q has some any value like a, b, c, d, e, there are any bits in a, b, c, d, you can swap d and a. So it will become b, c, d, a. Okay, b, c, d. So for this operation, you need to have p, and then you have to maintain p also. You need to swap bits in p also. Okay, and also need to take care of one thing like while swapping bits in p, it will automatically swap the bit in q at an index, like, right? No, it won't. Sorry, it won't swap. It won't swap any bit in P, but the swap on bit in P will affect directly the bit in Q because you want to rearrange your Q bits in such a way that you can convert them into R directly. There is no operation on Q which you can do other than flipping a bit and swapping. Okay, so to this problem we don't follow the we don't need to follow the operation in order. Okay, we won't go from top to down like first doing swapping bits or then replacing bits. Let's first see what is r and how r can affect q. Look, say there are count of zeros in R is C0 and count of uh, 1 in R is C1. They both need to be same in the queue, which means flipping of bits should be in such a way that count is maintained. Okay. So flipping of bits is should be in such a way that you maintain the count, because if R has something like this and you need to make by flipping your bits anything which has the same number of zeros and ones, and also after that you need to check if you can just replace these values, correct? You need to swap these values. So for this swapping, then you need to work on P. So what we will be doing in this problem, we will first check on R and then check how many need of bits we have and how many which we need to flip. After that, after flipping, I need to take care that if it is possible for me generating a particular P for this flip, which can after rearrangement, which can convert into R directly. Okay, so this will be my flow for this problem. Sorry. Now, if I say, how can I do this? So to do this, first write some conditions. Okay. Okay. Mm, so let's see what we can do. I can define um, first minimizing the flip, because is the only thing which cost flips. So let's start from here. I need to minimize the flip. So there are three cases, right? If uh, the bit on Qi is equals to bit on Ri. In this, you need only zero cost. Second condition is bit on Qi is 0 and bit on Ri is 1, which means you are on a need, which means you need some bit. So I have taken it -1. If bit on Qi is 1 and Ri is 0, which means you are on a surplus. Like you have a particular bit, but you don't need that. Okay. So I am denoting that as 1. So you can say this is group 0, this is group -1, this is group 1. Okay. And condition for them is this. Bits are same for group 0. Qi is 0 and Ri is 1, group -1. Qi is 1 and Ri is 0, groups 1. Okay. So for example, if Q was say 1 1 1 1 1 and R was say 0 1 0 1 0. Okay. What is the minimum number of flips which I have to do? They both are same. They both are same. I need to do three flips. Three flips. What is the cost function to get this three flips? It is just summation of Qi bits minus summation of Ri bits. Or you can just do like this also. correct? You can take modulus so that the answer going to undergo negation. Okay, so this is my cost function, which means the total number of bits which I need for flips, the minimum number of bits I need to convert QI number of bits into RI number of bits is just uh, summation of QI minus summation of RI. Now, let's define something, okay? Uh, let's check how many um elements from group -1 and group 1 can go into the string, okay? So, sorry. So for P also, I need to take care of one thing. Say there are two sets S0 which has all the indices on which pi is 0, okay, and S1 has all the indices where pi is 1, okay. Why I have done this? Because uh, as you know, P is responsible for rearrangement or swapping, not flipping, swapping, okay, swapping. Now, if P is responsible for swapping, and I can only swap if Pi is equals to Pj, which means these both bits are either zeros or either ones. So if both of them are same, I can make two sets in which first set contains all the bits where Pi is 0 and all the bits where Pi is 1. So I can track all the indices. Say for example, S0 contains 1, 2, 4 and 5 and S1 contains 3, 6. So this means I can swap only bits 1, 2, 1, 4, 1, 5, 2, 4, 2, 5 or 4, 5. Okay. And I can swap 3, 6. I cannot swap 1 and 3. So for this convenience, I have made two sets. I can't see chats. Okay. So these are my two sets. And now let's see how many elements from both the groups which I have made uh, for Qi to convert into Ri, which are -1 and 1. Let's check how many of them can go in these particular sets. Okay. So we can say, let's say X is the count of elements from group -1 goes into S0. Okay. We are currently talking about S0. Same goes for S1. It is completely same. And Y will be the count of elements from group 1 goes into S0. So these are two values. Element I means here those i's in which pi is 0. Okay. Alright. So this makes my cost for now. I have calculated all the cost for the q swappings to convert into r, which is just summation of qi minus summation of ri. And now I have to check for cost of p's. I have to flip some bits in p's also. correct? So what it will be like, if I see this is qi minus ri, right? I can also write it as qi minus ri. So say the number of bits mismatch in qi minus ri uh, will be equals to x is containing all the elements which come from minus 1 group. So x into minus 1 plus y into 1. Okay. So which is y minus x. Okay. You can rewrite this as x into minus 1 and y into 1, which is clearly means the total number of need of bits you need for swapping. Now coming for p bits which you need to flip. Now we need to pick x elements from group of minus 1 into our s naught set. Okay, so that we minimizes this flip on p. Okay, so let's get right here. See, if I put I in S naught, okay, S0 set, the cost is PI. Yes or no? Cost is PI. Why? Because if PI is 0, the cost is 0, and if PI is 1, the cost is 1. Correct. If I'm putting I in the S0 set, then it is a 0 set, which means if my the index is already 0, then I don't need to flip it. But if my index is 1 and I'm putting I in the 0th set, then I need to flip the bit. Okay, so it will give me a cost. Same goes for if I put I in S1, you can just do the same thing, or you can just write directly 1 minus of PA. Okay, this directly also, but if it is 1, then it will give the cost of 0. It is same. If PA is 0, it is 1, then if PA is 1, then it is 0. Okay, same thing for I in S1. Both of the set can be uh, written as this. So if I need to minimize the cost, I will prefer to put uh, indices which have pi equals to 0 into the S0 set, right? And indices with pi equals to 1 into S1 set. So I will try to do this so that my cost is minimum as possible. I don't need to flip a lot of bits. Okay. So if this is clear, then say then I can rewrite my cost function. My cost function is uh, x minus some value, say z. I have taken x and y, so I will take as z plus y minus z plus y minus x plus y minus x minus s of um what you can say, or you can say difference. Okay, what is z here? Z is count of indices from g minus 1 where pi is 0. Okay. So why I have done this? Because when you are putting all the pi which is 0 into the set as 0, it will minimize my cost. So let's say the count of indices which I have put is z. So it will decrease my cost of x by z and also y by z. Okay. I got TL in the third last test case. Which question? Flower on the floor. Which problem we are talking about? This one or third one? Give me a second. Okay. Which problem we are talking about? I can understand. So can you please write the problem name or problem number, which ABC, in which you have got the TL in the last third case. Okay, so let's continue. Now, how can we solve this, and how can we optimize this solution? Look, there are two variables, x and y. I cannot run for those two variables as n is 1e5, and I have know my earlier cost function was y minus x. So I can treat this y minus x, this y minus x, as some particular value u. Okay, so it is converted to some particular value u. Then what I can do is, this is a typical part for if there are two values you will need to work on, and the as you know the cost function is in the modulus and subtraction part. So you might know it is in the form of this. If you draw the graph, so graph will look like something like this. And if graph is looking like this, which means there is a monotonicity, no, it is changing once, you can perform ternary search on u or y minus x. Okay, so we will do ternary search. So your y is just x plus u, and after putting these value after putting this value in the equation, your equation will look like something like x minus z plus x minus z minus u, then u plus u minus difference. So your equation now don't have any y variable. All right, so you can just work on uh, this u using a ternary search. Correct. How can you do that? Anyone? Is this clear till now? So I can just move towards the approach. How can you just code it? Okay, guys. So first of all, what I have to search, this is the case. I need to search. Um, as you can see, this is minus and minus, so it will convert it to positive value. This is a positive value, currently positive, and this is also positive value. So I need to make my u. If you can say if I need to make u minimum as possible, and u is just y minus x, then x should be maximum and y is minimum. Okay, vice versa. If I need to make if I need to make u as maximum, then u is also y minus x. So y should be maximum and x should be minimum. Correct. So I can put my setup as my start will be the values, uh, say n1 and n2 are the counts. So my start will be a very small value, which is minus n1, and my end will be the largest value n2. So if this loop will work in this range, then you can just do a while. For ternary set, what you do is while your end minus start is greater than 2, greater than equals to, if you want to make an answer variable, you take two mids, mid 1 and mid 2. You can take mid 1 and mid 2 as start plus end minus start divided by 3, or end minus start divided by 3. Okay, so you can make two mids. After that, you need to make a predicate function, which is say my function f, and check for each mid 1. If it is less than your function mid 2, then you can say you have got a good range. So your answer, you need to minimize use, so answer should be in the mid 1 range. So you just update your end as your mid 2, as you update your start as mid 1. Okay, so this is just setup for ternary search. After that ternary search, you will get a small end and small a range of start to end, which is small. Then you can directly iterate from start towards end and check answer as minimum as answer for each call. You can run a call for my function and check for each mid. Okay. So for each mid between start and end, as after transition, the start and end will be a very small. You can just iterate over it directly. Then you will always get the minimum possible answer from this. Now, how will you make this my function? Okay, how will you make this? You are parsing mid in here. Okay, no one is here. Anyone? Uh, any doubt till now? Okay. So first of all, this mid is my u. Okay, keep in mind. So first of all, I need to calculate the valid range for x, for my x, and I know my x should be in the range n1, 0 to n1, and y should be in the range 0 to n2. Okay, This is my clear. Second thing, I know my u is just y minus x. Okay. So if I substitute this value in these, it will be like, or I can substitute in this. So I can write it as y is equals to u plus x. So 0 is less than x plus u is less than n2. Okay. So this equation can be converted into this format. After that, you can make your start pointer, sorry, start pointer as maximum of minus of u comma 0, because you don't need to go beyond 0, as range is maximum at 0. So you can write it as this, and your end will be at minimum of n1 comma n2 minus u. Okay. So your x range will be minimum at n1 and comma n2 minus 2, which is minimum. You can just traverse over it. Okay. So these are the setup for x. Correct. Now if your start ever get greater than end, you can just return infinity. All right. Now you need to determine the value like of the cost function. So my cost function was something like this: x minus z plus x minus z minus u, something like that, something like this, and rest of them, which was u and u minus diff, I guess. This was the cost function. So these are constant, right? Because after getting u, this is a constant. Correct. So I need to calculate for x. Currently x is this 2. So for that you can just target some value z which is closer to x. Okay. Target z closer to x, because this is open up to like this. So if you are iterating on u, you are getting a u constant in this. While in the predicate function, you get a mid as constant value. So you need to target z as closer to x to minimize the modulus part, or modulus, I'm saying this absolute difference part. Okay. These absolute brackets can be minimized only when the values in while in subtraction is as close as possible. Okay. So you just need to target z as close to x. Same, or either you can just target uh, this is x plus u minus z. So either you can target z closest to x or closer to u for this particular part. So there will be two targets: target to z closer to u. Okay. Now whichever is a smaller, you can work on that. Okay. So need to find the optimal x. What you can do, uh, this x must be in the range of these two targets. Let's say this is t1 and this is t2, so it will be in the range t1 to t2. Okay. Correct. You can just then iterate completely on this loop, and then iterate completely, and then just you can return the absolute value of u plus absolute value of u minus difference plus absolute value of x minus z and absolute value of x minus z minus u. Okay. So you can just return this after checking for all the x coming in this range or not correctly, after using some u, and from this you can just make your answer, check your answer as minimum as possible. So this was the problem, and if you look at the code is very similar to this. Okay. As you can see, uh, in this function, I have taken n ABC as input. ABC are my strings, so you can take PQR or ABC, and it will work. Now I have made n1 as 0, z1 as 0. Z1 and z2 are the two condition z's which I have talked about here, right? Z can be closer to x or z can be closer to u. So there are two conditions for z. So there are two z's. Okay. And SD is the difference of between the both the strings, or how much bits you need. Now I've just iterated over the length of the strings. If I have checked the difference between both the position bits of B and C. If they are 0, then I don't need to do anything. If there is -1, which means it comes in the group -1. So I have increased number of bits of -1 is plus plus. And if AI is 0, which means which I've taken out that if PI is 0, then I need to do an operation on that also. If P is 0 and I need to convert Q to 1 also, so I need to perform one operation, so Z plus plus. If it is 1, then I can increase the second group size plus plus, and if it is 0, then Z2 plus plus, which means the number of bits you need to flip in A was also increased. Okay, so total number of so difference between in both of them is n2 minus n1. It is clear. This is the size difference, and then as I mentioned for the ternary research, I have maintained my start is starting with minus n1 and end at n2. So to minimize the u as minimum as possible, I have done the ternary research. Your end minus start is greater than 2. Take 2 mids. Start plus end minus start divided by 3, and end minus end minus start divided by 3. And check for both of the functions. If it is coming on the mid one side, then update your end to mid 2, as you can update your start as mid 1. When after updating both of them, make your answer as infinity and iterate from start to end and check which ever gives the smallest possible answer, and then you can just output your answer. Okay, now this is my function thing. This is for x. I have to check for x. So in start, my x can, as we have talked in the equations, my x cannot be less than 0. So maximum of 0 comma minus u, and my x cannot exceed n1 minus or n2 minus u, because can replace y as u plus x, and when y was 0 to n2, and then it will be 0 to x plus u. It's just this. It's just this 0 to y to n2, and y was u plus x. So this is also true. Sorry. And if this is true, I can just subtract u from here. Correct. And also u from here. So this will convert your range into negative u and n2 minus u. Okay. So this is just basic maths. If you work on equations. Okay, if start is greater than end, it is an invalid range. I can return infinity. Now, if you check, see, I have made two targets. First one was Z1, which I need to make closer to X, and second one was Z2, which I need to make closer to U. So Z2 minus U will be closer to X. Okay. Now, if target one is greater than target two, you can just work on the smallest target first. Then your end x will be at some particular position, so I can check that position as if end is less than your target one, then it will be end. Else you will check for the start. If start is greater than target 2, then it will be start. Else you will take the maximum of start comma target 1. Okay, it's just directly you are trying to make your x in such a way that it start and end comes between the both the targets. Okay, after that you just return your absolute equation of the cost function which we were talking about, absolute of modulus of u minus difference, modulus of x minus z, and x minus z minus u. Okay, that's this. So this was the whole code for this problem. Is there any doubt or anything not clear? You can just ask. If not, I can just move towards the um, explanation of E problem. I was not able to solve, but it is the same in the E as, as we can discuss E along. It's a quite a hard problem to be noted. Like in this problem, in the previous problem, you were just asked to find F, A, B, C. Okay. In this problem, you have to find for all the substrings of any size 0 to n, you need to find F, F, A, B, C, F, A, L to R, B, L to R, C, L to R, and take the summation of all of that. So in this here, you need to do some range queries. So Fenwick tree or segment tree will help. Your approach will be same as ternary search, but you need to work on Fenwick tree. I guess a lot of Fenwick tree will be made in this, like six or three. I guess three or six Fenwick tree will work on this problem. But you just need to find the summation of all the ranges from L to R, and it's a quite hard problem. So you can just try on your own using. There are maybe multiple approach, and maybe I am wrong for Fenwick tree. I'm not sure, but Fenwick tree will work. You need to make ranges on that. You can put all the ranges on that tree, and you can make like uh, three four things. Like currently my first my x was bi minus ci summation of which means pqi minus pi, right? Ri for ai equals to 0 and y was same, and the cost function will be same for both of them. The thing that changes is just the number of indices. So you need to put all the cost function on each of the indices, and after that you can just make a bit to solve that. So it's you can just try on your own. You will if you try to solve this, I guess you will get a particular approach for this problem. And that's it for my side. If you have any doubts, you can just ask, or we can just end the stream. Any doubt if you have regarding any of the problem or general doubts? If no, then okay. Thank you for joining in the stream. I hope you were able to understand each of the problem which are being discussed here. If there is still any doubt, you can just comment on the video and I will check and try to resolve your doubt. And thank you for joining and have a good night ahead.